Hello everyone, in this video I'm going to discuss the example for limits. Given we have the function fx is equals to 5 over x minus 1. A. Determine the domain. So kindly refers to the function we have 5 over x minus 1. So this part is the constant. If it's a constant, the domain for the constant would be negative infinity until infinity. Next, refers to the denominator. As we all know, x minus 1 is a linear. So initially, it is a all real number, or we can say it from the negative infinity until infinity. But for this case, as we all know, x minus 1 cannot be equals to 0 because it will be undefined. X cannot be equals to 1. So simplify the situation. Negative infinity until 1. Union from 1 until infinity, where the 1 is not included. So based on the situation, here we have the division. So the meanings of the division would be intersection. So as a conclusion, negative infinity until infinity intersect with the situation negative infinity until 1, union 1 until infinity, when the 1 is not included. So the domain would be negative infinity until 1, union 1 until infinity. So that is the domain for this situation. Continue. Find the x and y intercept of the function fx. So x intercept and then we have y intercept. In order to find the x-intercept, y must be equals to 0. Kindly substitute. So we have 0 is equals to 5 over x minus 1. So if we cross multiply, and we will have 0 is equals to 5. So as we can see, there is undefined. For the x would be undefined. So we can say that y is equals to 0 would be the horizontal asymptote. Then we can say x-intercept does not exist. Next, continue. In order to find the y-intercept, x is equals to 0. So y is equals to 5 over negative 1. Y will be equals to negative 5. So the points of intersection would be 0, negative 5. So the answer for the B would be x-intercept does not exist, and then y-intercept we have 0, negative 5. Next, continue. Find the vertical asymptote and horizontal asymptote. So here we have the vertical asymptote. By referring to the domain, here we have the situation x is equals to 1 is a vertical asymptote. We need to determine the behavior for the vertical asymptote as approaching from the left and also from the right. So limit when x approaching 1 from the left for the function 5 over x minus 1. Limit when x approaching 1 from the right for the function 5 over x minus 1. So let's say we had a value which is from the left approaching the 1 will be 0.99999. So if we substitute, we will have the situation 5 will be the positive, and then we have 0.9999 minus with the 1 will have a very small value. So we will have the negative infinity. Continue. When x approaching 1 from the right, we will have the value 1.00001. So for this part, we will have the positive infinity. So the vertical asymptote is x is equals to 1. Next, we need to determine the horizontal asymptote. So as we can see here, we already mentioned that y is equals to 0 will be the horizontal asymptote. So limit when x approaching negative infinity. Another one, limit when x approaching positive infinity for the function 5 over x minus 1. So if we substitute the value, we will have 5 over negative 1000 minus with the negative 1. So by referring to the calculator, and we will have the value approaching 0. Next, limit when x approaching positive infinity, we will have 5 over x minus 1. Let's say we have the value positive infinity will be the 1000. So 5 over 1000 minus 1. If we substitute, we will have the value approaching 0. So as we can see here, the horizontal asymptote y is equals to 0. Next is to sketch the graph. Here we have the xy axis. Kindly refers to A. Determine the domains of the function fx. So here we have the domain negative infinity until 1 union 1 until infinity. The 1 is not included. So that is the vertical asymptote. So kindly illustrate the situation. So here we have the vertical asymptote, x is equals to 1. Continue. The xy intersect. As we all know, there is no x-intercept, but there is a horizontal asymptote. So kindly illustrate the situation, horizontal asymptote. So here we have y is equals to 0. Continue. We have the y-intercept 0, negative 5. So let's say here we have negative 1, negative 2, negative 3, negative 4, negative 5. 0, negative 5, y-intercept. Continue. Vertical asymptote. So referring to the vertical asymptote, we have the behavior. As the x approaching 1 from the left, we will have negative infinity. So this will be the situation, negative infinity. When x approaching 1 from the right, we have the positive infinity. So here will be the positive infinity going up, increasing. So previously is decreasing. Continue. We have write down the vertical asymptote where x is equals to 1. Next refers to the horizontal asymptote. We have y is equals to 0. As x approaching negative infinity means that towards the left, it will approaching the value 0. So here we have two situations, above the 0 or less than 0. Another one, when x approaching positive infinity means that towards the right, they will approaching the value 0 as well. So here will be the situation. So kindly refers to the calculator 5 over x minus 1. So if we substitute a value, let's say for the negative infinity, we substitute negative 50. So very obvious, we will have the value which is less than 0. That's why we said as x approaching negative infinity, the value will be approaching 0, then we will have a value less than 0. As for the right hand side, when the x approaching positive infinity, so kindly substitute the value, let's say x is equal to 50 into the calculator, and we notice that we will have the value which is approaching 0 and it is a positive value. So for this part, the value of x, when x approaching positive infinity, the value of y would be greater than 0. So the curve will be something like this. Then for this part also, so that is the function fx is equals to 5 over x minus 1. So we have the xy intercept and the vertical asymptote, same also for the horizontal asymptote.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.